Alright, so in this video we go over section 12.5, the binomial theorem. So in this case, in this section we are going to learn how to raise binomials to any natural number power, for example. Well, the idea of this, well, when you might remember how to raise a binomial to the second power. Well, so in this case, what you would do is write this a plus b quantity square as a plus b times itself. Alright, and then from here you would FOIL like this, so that's a squared plus ab, and then FOIL, keep foiling here. B times a is the same as ab, and then b times b, that's b squared. And then ultimately this is a squared plus 2ab plus b squared. Alright, be careful because very often time is very common to make the following mistake, that this is equal to a squared plus b squared, which is not correct. You don't want to do that. Alright, well, what if you wanted to raise a binomial to the third power? Alright, well, one alternative is to write this as a product of these 3 times, but well, in this case, you can write this as a plus b times a plus b squared. Instead of doing this 3 times, you can do it 1 to the first and 1 to the second. And then my advice here is to, well, just use the result from the previous part. A squared plus 2ab plus b squared. Alright, and then use the distributive property from here. A times a squared, a times 2ab, a times b squared. So what are we gonna get? Well, so a cubed, and then a times 2ab plus 2a squared b, and then a times b squared plus ab squared. And then finally, b times a, b times 2ab, and then b times b squared, which in this case is b times a squared, which is, well, plus b times a squared. I'm just going to say a squared, b, I'm just going to write them in alphabetical order, and then a b times 2ab, that's plus 2ab squared, and then b times b squared, that's b cubed. And then from here, what do we do? Well, combine like terms. Well, like this one with that one, and these two are also like terms. So what we get in the end is a cubed plus 3a squared b plus 3ab squared plus b cubed. Alright, I mean, for raising a binomial to the third power, look at the amount it took. Look at the amount it took. I mean, doing the binomial square, well, that's something we did very often times during the semester. Well, but in this case, it was very shorter, to do. But in this case, the binomial cube took a little longer. What if you want to do a plus b to the fourth power? What about a plus b to the sixth power? Of course, I mean, do you want to FOIL this 6 times? Well, I mean, that may not be that practical. So in this case, what we're going to do is use the binomial theorem, which in this case, well, consider the 2 quantities a and b raised to a power n. In this case, n is a positive integer. It's a natural number as well. And well, in this case, this is the sum going from j to n of n choose j times a to the n minus j, b to the j. Well, and it's expanded in this way. I know this formula is kind of huge, and there's some notation that we may not have seen before, So like this n j. This is not a fraction. Be careful. These are the binomial coefficients, and the binomial coefficients are defined in the definition before in the box below. Not before, actually below. And well, if we consider n and j being natural numbers, those are going to be the exponents on the binomial theorem. This expression is red, actually red, and choose j, and it's called the binomial coefficient, and it's evaluated in this form: n factorial divided by j factorial times n minus j factorial. So we're going to work with factorials for a little bit, and so you'll see how is this going to look like. All right, so let's see. So let's do one example of how to use the binomial theorem to raise the quantity x plus 2 to the 5th power. Alright, so what are we going to do to raise x plus 2 to the 5th power? Well, number one, x plus 2 to the 5th power. So this will be the sum, alright? So this will be the sum from j equals to 0 to n equals to 5. So notice a equals to x, b equals to 2, and n equals to 5. Alright, so we need to identify our terms here. And then in this case, this is going to be n and j according with the formula. Let me put it up here. N, which is 5, and then we're going to go just j. All right, and I'll show you how are we going to do that part. All right, and then that's a to the n minus j, so a, which is x, to the n minus j, which in this case j, let's just call it j, and then b to the j, so in this case times 2 to the j power. Alright, so the way we are going to expand this, we are going to plug in all the j's from 0 to 5. So what we're going to do is 5 comma, I'm going to put 0, okay, 5 comma 0 times x to the 5 minus 0 times 2 to the 0. So 5 minus 0, 2 to the 0. And then plus 5, 1, 5 choose 1, x to the 5 minus 1, 2 to the 1. So 5 to the 1, 2 to the 1. Plus 5 choose 2, x to the 5 minus 2, 2 to the 2. And then plus, let me keep going here, plus 5, 3, 5 choose 3, x to the 5 minus 3, 2 to the 3, actually, could have been better in green, 3. And then plus 5, 4, x to the 5 minus 4, 2 to the 4. And then the last term will be when we get all the way all the way to 5. So in this case, 5, 5, x to the 5 minus 5, 2 to the 5th. All right. Okay, so we need to evaluate these quantities: 5, 0, 5, 1, 5, 2, 5, 3, 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5, in order to keep going with this. Okay, so we're going to use the definition of the binomial coefficients to evaluate those expressions. So let's see. So let's first do, I'm going to use a different color for this, actually, just to so we can make a distinction. This is not part of the procedure. I'm gonna do this on the side. So I'm gonna do 5 0. 5 0. That's gonna be n, which is 5. 5 factorial divided by j, which is 0 factorial, times n minus j, 5 minus 0 factorial. All right. So in this case, well, recall from a couple of sections ago, 0 factorial is 1. So 5 factorial over 1 over 1, actually, simply 1, and 5 minus 0, that's 5 factorial. So in this case, we can simply divide this out, and this is going to be 1. All right. Let me put a box in it. Let's do the second one. 5 choose 1, so 5 factorial over 1 factorial times 5 minus 1 factorial. So in this case, okay, let me skip the factorial part for a second. So 5 factorial over, okay, 1 factorial is simply 1. I'm not going to write that 1. And then this is 5 minus 1, which is 4 factorial. All right. Even though there are, calculator functions to evaluate factorials, so sometimes it's shorter to do it by hand, So let me just real quick show you how to work with factorials. For example, 5 factorial, that's the same as saying 5 times 4 times 2 times 3, times 3 times 2 times 1, okay, all the way, multiplication of all the integers below 5 all the way to 1, But another way to represent this is 5 factorial equals 5 times 4 factorial, because 4 factorial is all this product here. 4 times 3 times 2 times 1. Another way to say 5 factorial is 5 times 4 times 3 factorial, because this 3 factorial is the same as multiplying this 3. 3 times 2 times 1. Another way to say 5 factorial is the same as saying 5 times 4 times 3 times 2 factorial, because this 2 factorial is the same as the product of these two. So the factorial expansion of a number, and well, it may not be, it's not unique, we can make it represent in different ways depending on our needs. And by depending on our needs, for example, I would like to cancel this 4 factorial. So what I'm going to do is 5 times 4 factorial over 4 factorial. And in this case, we can divide out the 4 factorials and end with a 5. So that's, let me box this result. For example, what if I had something like 9 factorial? Well, let me actually keep using the 5 factorial example, but instead of dividing by 4 factorial, we are in the need of dividing by 3 factorial. So in this case, I would need to do 5 times 4 times 3 factorial. So I can cancel this 3 factorial. Boom, boom. 5 times 4, that's 20. This simplification is useful, for example, when you have factorials of huge numbers. For example, what if you wanted to do, I don't know, maybe something like 26 factorial divided by 25 factorial. If you put it just like that, one individual, and then divide the numbers, the calculator may not even give you this. So you would have to do, well, let me actually do 27. So 27, so that'll be 27 times 26 times 25. And in this case, factorial over 25, factorial cancel. 27 times 26, well, that will be 702. 702, So that'll be the answer to that. So that's how we simplify factorials, So, and let's keep doing this. So now let's do the 5 choose 2. So that's 5 factorial over 2 factorial times 5 minus 2 quantity factorial. So 5 factorial, let's leave it like this for a second. Let's leave it like this. 5 factorial. 2 factorial is 2. 5 minus 2, that's a 3 factorial. Alright. Again, did you remember when I did the 3 factorial? So I'm going to do it in this case. So I'm going to go 5 times 4 times 3 factorial over 2 times 3 factorial. And see how this go away. Cancel, cancel. And 5 times 4, that's 20. 20 over 2, that's 10. That's another. So in this case, let's keep going with the next one. 5 choose 3. So that's going to be 5 factorial over 3 factorial times 5 minus 3 factorial. Okay, but what's okay, let's leave the 5 factorial at the top. So 3 factorial, I'm gonna do so 3 factorial times 2 factorial. I'm going to simplify preferably the largest possible, so we don't have to expand factorial too many times. So that's 5 times 4 times 3 factorial, and that's over 3 factorial times 2 factorial, which is 2, because 2 times 1, and then that's a 2. And in this case, goodbye, these 2. And we get the same answer as before. 5 times 4, that's 20. 20 over 2, that's a 10. Alright. I know, this is painful to do. This is a lot of work, but I'm going to show you a way to avoid all this work working with factorials. So let's do a couple more. 5 choose 4. 5 choose 4. So that's not supposed to be fraction. 5 choose 4. That's 5 factorial over 4 factorial. 5 minus 1 factorial. So 5 factorial over 4 factorial. And then, 5 minus 4. That's 1 factorial. But 1 factorial is simply 1. And then in this case, we do 5 times 4 factorial over 4 factorial. 1 factorial is the same as 1. I don't need to write that one. Goodbye. And this is 5. And last but not least, 5 choose 5. So that's 5 factorial divided by 5 factorial times 5 minus 5 factorial. So this is going to be 5 factorial actually. Well, these cancel. And 5 minus 5. 5 minus 5 is 0 factorial. But 0 factorial is 1. 1 over 1 is 1. So we just found the coefficient, 6 coefficients. So now, let me keep going here. Let me go back to blue, which is the exercise that we are going over here. So, let me use the space below. So this is, x plus 2 to the 5th power equals 2. Okay. So we have x to the 5 minus 0, which is 5. 2 to the 0. Any quantity to the 0 is 1. So I'm just going to write that one like that. And I'm going to leave some spaces, by the way. I'll show you why in a minute. Well, actually, that's going to be the first coefficient, is 1. Right, this one right here, plus the next coefficient, which is 5. And then x to the 5 minus 1. 5 minus 1 is 4. 2 to the first is 2. Plus 5 choose 2, which in this case is 10. Alright, in this case this is 10. And this is x to the 5 minus 2, which is x to the 3rd, 2 to the 2nd, which is 4, plus another 10, which is the 5 choose 3, times x to the 5 minus 3, which is 2, and 2 to the 3rd, which is 8. And then plus x to the 5 minus, or actually, that's the coefficient first. In this case, is 5. X to the 5 minus 4, which is 1 to the first power, 2 to the 4th power, which is 16. And last but not least, 5 choose 5, which is here, that's a 1, times x to the 5 minus 5, that's x to the 0. If we will, I'm going to put the x to the 0 power, and then times 2 to the 5th power, which is 32. And all we do is simplify all here. So that's 1 times 1, which is 1 times x to the 5th. 2 times 5, which is 10, x to the 4th power. 4 times 10, that's 40, x cubed. And then 10 times 8, that's 80, x squared. 5 times 16, that's another 80, but times x to the first. And then x to the 0 power is 1 times 1, that's 1 times 32, that's plus 32. And that's final answer. Is there kind of a shorter way to do this? Well, yes. Luckily, we have a great tool called the Pascal's triangle. In this case, to avoid all this computation of the binomial coefficients, and it's given right here. It's a crazy triangle. So depending on the binomial that we want to compute, for example, if we want to compute the binomial square, do you recognize these numbers 1, 2, 1 from the first first page? So that's basically 1, 2, and 1. If we want to raise a binomial cube, that the binomial coefficients are 1, 3, 3, 1. Isn't that what we have here? 1, 3, 3, 1. Oops, it's supposed to be here. Sorry. 1, 3, 3, 1. So, for example, if you wanted to raise a binomial to the 5th power, what are the coefficients? 1, 5, 10, 10, 5, 1. Isn't that what we have here? What we got here? 1, 5, 10, 10, 5, 1. Exactly the same values. How is this Pascal's triangle constructed? Well, we start with a 1 on the cusp of the pyramid or the triangle. All the sides have a 1, have 1s in it. So I'm going to go to the second row. I'm going to add 1 plus 1 is 2. And then to get this 3, I'm going to add 1 plus 2 equals 3. 2 plus 1 equals to 3. And then 1 plus 3 equals to 4. 3 plus 3 equals to 6. 3 plus 1 equals to 4. And, well, we keep the 1s along the sides. 1 plus 4 equals to 5. 4 plus 6 equals to 10. 6 plus 4 equals to 10. 4 plus 1 equals to 5. And if you keep it going all the way to this, you should be getting this. You can actually construct this Pascal's triangle. Of course, what I did here is just give you all the way to n equals to 14. Those are the coefficients of a binomial being raised to the 14th power. Hopefully you don't get anything like that, but I mean, just in case you're curious, I mean, this is what we would do. And we're going to use this instead of evaluating this crazy sum, this crazy binomial coefficient. But I mean, it's important to do at least one example using the definition and then look at some kind of a shortcut, if you will. I mean, it's not necessarily a shortcut, it's just a different way, and in fact it saves us some time. Another way, another pattern that you might want to recognize here. So when we raise binomials to a power n, notice how the power, so we start with the first term raised to the nth power, and the power of the first term decreases by 1 each next term, in the same way that the power of the second term increases as we go. For example, right here, a has a power of 2, has a power 1, and then has a power 1, and then it has a power 0. B ends in power 2. It previously had power 1, and this is basically having b to the 0. Same thing here. Observe a for the binomial cubed. Observe how a starts to the third power, decreases by 1 power, 1 more, and then a to the 0. And then b to the 0, b to the first, b squared, b cubed. All right. So in this case, if you do the power a to the 4, let me do the a to the 4 just real quick. So a to the 4. Well, let me actually okay. Let me turn this 6 into 4. So a to the 4 plus a cubed b plus a squared b squared plus ab cubed plus b to the 4th. All right, see how the powers of a decrease as the powers of b increase, and then in this case I'm missing the coefficients, and the list of coefficients come from here, from Pascal's triangle in this case. So let me put it up here so you can see what I'm doing. So I'm gonna go to a equals to 4, n equals to 4, 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. So we don't have to compute this coefficients in this crazy way, in this time-consuming way. All right, so let's do another example. So for the next example, actually we're gonna do a couple of examples more. So use the binomial theorem and Pascal's triangle to expand 2x minus 3 to the 6th power. So we're going to do a binomial to the 6th power. But we're not going to do, notice the space we are given here, so we're not expected to find or to compute the binomial coefficients. We are going to use the binomial coefficients from here, from the Pascal's triangle. So 2x minus 3 to the 6th power. Alright, what are we going to have? Be careful here, because in this case the negative sign is going to have an impact. So a equals to 2x and b equals to negative 3. Alright, so what are we going to do? So we are going to start with a. Well, let me actually use pink for this, and pink for a, green for b. So to the 6th power, and then to the 0 power. So in this case, what are we going to have? 2x and negative 3. Plus, I'm going to leave some space for the binomial coefficient. 5, 1, negative 3, and 2x. And then plus, leave space for the binomial coefficient. 4 and 2 plus, well, let me actually do the powers. Coefficient 3 plus 2 4 plus 1 5 plus 0 6. Another pattern to notice, okay, what I mentioned earlier, powers of a decrease as powers of b increase. But another interesting pattern to observe here, the powers of every single term always add up to n. In this case, n equals to 6. 6 plus 0, 6. 5 plus 1, 6. 4 plus 2, 6. 3 plus 3, 6. 2 plus 4, 6. 1 plus 5, 6. 0 plus 6, 6. So that's way shorter. So let me put the pings. 2x, 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 2x. And then negative 3, negative 3, negative 3, negative 3, negative 3. Alright, it's time to put the binomial coefficient. So in this case, for the binomial coefficients, I'm going to use Pascal's triangle. Alright, so we're going to go with n equals to 6. So I'm going to highlight the coefficients of n equals to 6. These ones, these are the ones I'm going to use. Alright, so let's see. Let's put them here. And so this is an invisible one. I'm just going to write it, even though it's not necessary. 1, 6, 15, 20, 15, 6. Wait. 1, 6, 15, 20, 15, 6, and 1. Alright, and we're done. So we're done setting up the problem. The rest is only algebraic manipulations. Alright, so let's see. So in this case, x minus 3 to the 6th. Oh, okay. So negative 3 to the 0 power is going to be positive 1. Positive 1 times 1, well, that's going to be 1. So this is going to be 2 to the 6th power times x to the 6th power. Let's just leave it like this for a second. And then in this case, be careful with the signs, because negative 3 to the first is negative 3 times 6. That's going to be negative 18 times 2 to the 5th, x to the 5th. And then negative 3 squared, it's positive 9, that's a plus. 9 times 15, let me use the calculator. 9 times 15, 135. Times 2 to the 4th, x to the 4th. Plus negative 3 times, negative 3 to the 3rd power, that's negative 27 times 20. Negative 27 times 20. Using my calculator, I get actually negative 540. X to the, well, actually not x yet. I'm missing the 2 to the 3rd times 2 to the 3rd times x to the 3rd. And then let's go with this term. Plus, in this case it's plus because it's a negative being raised to an even power. So that's 3 to the 4th, that's an 81, I believe. 3 to the 4th, that's 81. So 81 times 15, let me multiply that by 15. I get 1215. And then 2 to the 2nd, don't forget that 2 to the 2nd. X to the 2nd, or x squared. Plus 3 to the 5th power, okay, 3 to the 5th, that's 243, negative 243 actually, that should be negative. So notice I'm making those silly mistakes like real quick, but I'm changing them. Be sure not to get those mistakes when you're doing this. And so that's 3 to the 5th, that's 243 times 6. We get 1458 x and 58 x to the 1st times 2 to the 1st times x to the 1st. Okay, and then the last term, that's going to be negative 3 times negative 3 to the 6th power. So 3 to the 6th power, that's 729. 729 times 1, that's 729. And then 2x to the 0 power is simply 1. I'm not going to write that one. So the rest of this is simplifying the coefficients. Well, 2 to the 6th power. So 2 to the 6, that's 64. X to the 6th power minus 2 to the 5th, which is 32. 32 times 18, it's 576. X to the 5th power. 2 to the 4, which is 16 times 135, we get here plus 2160. X to the 4th. 2 to the 3rd is 8 times 540. 43 minus 43, 120, x cubed. 2 to the 2nd, which is 4 times 1215. That times 4, we get 4860 x squared. And then 2 times the quantity 1458, that's 21 minus 29, 116 x plus 729. All right, and this is final answer. All right, final answer to this. So I mean, even though it takes a minute, it takes a good minute to get this done, at least it's shorter than actually doing the binomial coefficient and then putting them together. Definitely Pascal's triangle helps us a lot. Let's do another one. So we're gonna do one that requires x to the 8th power. So what are we gonna do there? Well, so in this case I would rewrite this as x to the 1/2 minus 1, where n equals to 8, a equals to x to the 1/2, and b equals to -1. And again, I'm going to use the same color coding here. Pink for a and green for b. All right, so yeah, this one is going to take a good minute, I think. So x to the 1/2 minus 1 to the 8th power. Okay, so I'm going to quantity to the 8th to the 0 plus space for binomial coefficient 7, 1 plus binomial coefficient 6, 2 plus binomial coefficient 5, 3 plus binomial coefficient 4, 4 plus binomial coefficient 3, 5 plus binomial coefficient 2, 6 plus binomial coefficient 1, 7, and plus binomial coefficient 0 and 8. All right, so let's put the a's. So a's, that's x to the 1/2 to the 1/2, x 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 to the 1/2. And then let's put the b's with green, -1, -1, and now let's put the binomial coefficients. Those we get them from Pascal's triangle, again using n equals to 8. N equals to 8, we are going to use all these coefficients. 1, 8, 28, 56, 70, 56, 28, 8, 1. All right, let me make this a little bit more visible. Okay, so 1, 8, 28, 56, 70, 56, 28, 8 and 1. Alright, the rest of this is only simplifying all of this. Alright, so let's, this is where the fun begins. So, square root of x minus 1 to the 8th power. Alright, so negative 1 to the 0 is 1. 1 times 1 is 1. X to the 1/2 raised to the 8th. Well, product, a power of another power, multiply the power. So 1/2 times 8, that's 8/2. But 8/2 reduces to 4. And then over here, be careful. Negative 1 to the first power is negative 1 times 8 is negative 8. And then x to the 1/2 times 7, well, that's simply 7/2. No need to reduce any further. I mean, these do not go evenly. Negative 1 squared is positive 1 times 28, that's plus 28. 28, and then x to the 1/2 to the 6th. Multiply the power, 6 times a half, that's x to the 3rd. Negative 1 to the 3rd is negative 1 times 56, that's a negative 56. X to the 1/2 times 5, that's simply 5/2. And then negative 1 to the 4th power, that's a negative, that's positive 1 times 70, that's a plus 70. X to the 1/2 to the 4th, that's the same as saying 4 times a half, which is 2, x squared. Negative 1 to the 5th is negative 1 times 56, that's a negative 56. X to the 1/2 to the 3rd power, multiply the powers, 1/2 times 3, that's 3/2. Negative 1 to the 6th, that's positive 1. Positive 1 times 28, that's 28. X to the power of another power, 2 times a half, that's x to the first power. I'm not going to write that one, we don't need to. And then last but not least, oh no, we're not done yet. Negative 1 to the 7th power is negative 1 times 8, that's a negative 8. X to the 1/2 times 1, that's 1/2. And the very last term, negative 1 to the 8th power, that's positive 1 times 1 is 1. And then x 1 to the 1/2 to the 0 power is also 1. Any quantity to the 0 power is 1. So we basically have the product of 1 times 1 times 1, which equals to 1. And this is final answer for this example. All right. Okay, so sometimes you will be asked, for example, in the homework or the exam or something, to find a particular coefficient or a particular term. And doing the entire expansion, well, that's going to be, it might be a little bit, a lot of work to just look for a particular term. For example, in example 4, they're asking us to find the coefficient of y squared in the expansion 2y plus 3 to the 10th power. Well, you don't want to do all the expansion, actually 11 terms, so just identify one. So in this case, we are just going to use this this formula right here. So in this case, having an expansion of a plus b or minus, depending on the sign, to the end, the term containing a to the j, well, it's given by this expression. So for example, in this case, we have n equals to 10, a equals to 2y, b equals to 3, and j, well, j equals to 8, right? So we're looking for the term containing x to the coefficient containing x to the power j, which in this case is 8. So let's evaluate this. So n, choose n minus j. Let's write simples first. A to the j, b to the n minus j. Well, n in this case is 10. And then choose 10 minus j minus 8. That's the quantity a. The quantity a, which in this case is 2y. Oh, actually, it's not equal, so that's 2y. n to the j power, which in this case is 8, times the quantity b, which in this case is 3, to the n minus j, so 10 minus 8. And in this case, well, let's simplify this. 10, choose 2, and then 2 to the 8, y to the 8, 3 to the 10 minus 8, that's squared. Alright, so in this case, let's evaluate the quantity 10 choose 2. So in this case, that's a 10 factorial over 2 factorial times 10 minus 2 factorial times the quantity 2 to the 8. What is 2 to the 8? 2 to the 8th power, that's 256. Y to the 8 and 3 squared, which is 9. Alright, so this is going to be 10 factorial divided by 2 factorial, which is 2, and 10 minus 2, that's an 8 factorial. 256 times 9, that's 2304 y to the 8. Alright, so in this case, well, I'm going to simplify this factorial. I'm going to break it up into 10 times 9 times 8, but I'm going to stop here and write down factorial so we can cancel this 8 factorial here, times 2304 y to the 8. And in this case, goodbye. And what are we going to get? 10 divided by 2, that's 5. 5 times 9, that's 45. 45 times 2304, so that times 45. That's, we get 103,680 y to the 8th power. But in this case, what are they asking us for? They're asking us for find the coefficient. So the coefficient will be this number right here. So that's what we're looking for. Alright, so let's look at the last topic for this section. Find a particular term. So be careful. In some cases you will be asked for the coefficient of a particular term, but in this case you are going to look for a particular term, you know? Like in this case, we're looking for the fifth term of x plus 5 to the 11th power or something like that. Alright, so the formula is a little bit different, so be careful. And the question is it might look a little bit simple, but again, you're looking for the kth term, not for the coefficient of x to the something or y to the something, depending on the variable. So find the sixth term of in the expansion x plus 2 to the 9th power. Of course, you don't want to expand all the terms and then identify the 6 terms. No, you're going to use the formula. Okay, let's list. Number 1, n equals to 9. That's the power of the binomial. You want to look for the kth term, which in this case k equals to 6, the 6th term. Alright, and in this case, R, we're going to need R. R is actually k minus 1. R equals k minus 1, which is 6 minus 1. And then we also need to highlight what A and B are. So A equals to x and B equals to 2. Okay, again, I'm going to use the same color coding. Alright, so you can see what am I plugging in and where. So let me write down the formula. N choose R times A to the n minus R, B to the R. Okay, so, and in this case, n equals to 9. 9 choose R, which in this case, that's a 5. Okay, that's a 5. And a, which is the quantity x, raised to the n minus r, in this case 9 minus r minus 5, and the quantity b to the r, which is 5. And in this case, x, and in that case, 2. Alright, so we keep simplifying this. I'm going to set this up as the binomial coefficient, so that's a 9 factorial over 5 factorial times 9 minus 5 factorial times x to the 9 minus 5 is 4, to the 5th is 32. And in this case, well, so we need to keep simplifying. So 9 factorial divided by 5 factorial times 4 factorial. Well, in this case, I'll explain something interesting here. So you might want to simplify the largest of the factorials with the largest in the denominator. In this case, the largest in the denominator is the 5 factorial. So 9 times 8 times 7, I know this is going to be a little bit crazy, times 6 times 5 factorial. Stop there. 5 factorial, 4 factorial, that's x to the 4th power times 32. All right, 32. And then in this case, well, number 1, we can divide out these 5 factorials. And then let's evaluate 4 factorial. What is 4 factorial? 4 factorial is the same as 4 times 3, which is 12, times 2, which is 24. So 9 times 8 times 7 times 6 over 24. X to the 4th times 32. Alright, so let's do this multiplication right here. So that's 9 times 8 times 7 times 6 divided by 24. What we get times 32. And that's 432 x to the 4th power. So this is the 6th term of this binomial expansion. If you do the binomial expansion for this binomial, the 6th term will be this right here. Instead of doing the whole thing, we can just use the formula and investigate which term it is without the need of doing the remaining. Alright, so this is the end of this section. So I'll see you in the next video.